Welcome to the Evaluating AI Quantum Computing to Drive True AI to Aid Defensive Cyber Operations Theater session at TechNet Cyber. I am Josh Ranke, Program Manager with Mantech, and we are a proud supporting partner of TechNet Cyber. I am pleased to introduce our next session on behalf of AFCEA International. Steve Wallace is the Chief Technology Officer and Director, Emerging Technology Directorate for DISA. The Emerging Technology Directorate develops, executes, prioritizes, and collaborates EM-based needs such as zero trust, 5G, quantum resistant cryptography, and DoD IT standards to deliver innovative processes, services, and capabilities across the agency. Steve Wallace has a master's degree in cybersecurity, a bachelor's in telecommunications, and previously worked as a government contractor prior to joining DISA. At this time, I'll turn over this great session to Steve Wallace, who will introduce the other panelists.
All right. Thank you very much. Holy cow. I did not expect all of you out here this morning, but thank you very much for joining us. So let me start by introducing our panel. When the opportunity for this thing came up, I'll use the term gentlemen, we'll see by the end of this, but these gentlemen were kind enough to volunteer their 0815 on day one, but I wouldn't have it any other way. They were the first choice for the folks that we wanted for this panel. So I'll start with Jason here. Jason, I will just go down the row, and if you kind of want to introduce yourselves and where you work and what you do.
Yeah, so Jason Abernathy, I'm the Division Chief for ID6 and Portfolio Manager for PEO Cyber. Probably the least qualified person to be sitting on this panel, but I appreciate the invite. Thank you.
Minus the JRSS history, no.
Yeah, don't hold that against me.
Yeah.
Hi, Jared Sanders. I'm one of our AI engineers in the Emerging Technology Directorate. So I joined DISA in December. Prior to that, worked for Amazon for a couple of years, and then a little over 10 years as an integrator. So like Jason, sharing an imposter syndrome on the stage here, but yeah, excited for the conversation today.
Deepak?
Thanks. Good morning, everyone. My name is Deepak Seth. I'm a Chief Engineer in the Emerging Technologies Directorate. I've been in EM for about 5 years now. I mostly focus on AI and quantum-resistant cryptography. I also spent about a year and a half as a detailee at the Joint AI Center when it was started a couple of years back. So, thank you.
Hey, my name is Rasha. I'm a Director of Enterprise Engineering and CXO for DISA, and data is visualization is kind of my pet peeve. Started with Trusted Workforce 2.0 and NBIS. If you remember, I was architect of that, and now doing this to improve the user experience as well as engineering. Thanks, Jay.
All right, thanks, guys. So we're going to get right into the questions. We'll save some time at the end for questions from you all, if you'd like. So a lot of times when folks think of DISA, they think, oh, you're just transport. That's what you guys do. You just run wires, cables. You're the plumbing company. Over the last several years, we've worked really hard to drive the concept of innovation within the agency. It is everyone's responsibility, whether you are on the technical side of things, whether you're on the procurement side of things, all kinds of different aspects across the agency. So guys, can you start by how in your own respective organizations we're encouraging the culture of innovation to look at and evaluate the deployment of technologies. We're here today to talk about QRC, AI, ML, but whatever direction you'd like to go.
Yeah, so I'll start. So inside of PEO Cyber, not doing a lot with quantum, but in the AI realm, we're evaluating a lot of products as far as how do we increase not the user experience but the analyst experience, right? So how do I make their job more efficient, automate some of their tasks, and also where I'm exploring is leveraging AI in areas of looking at the vast amounts of data that we're pulling in from the IPs and from the additional sensor points we have across the network. So I see an AI future where that's gonna help our analysts not just find what we know is bad, but give us insights to what we're not seeing and what we're missing just in those large areas. So.
Cool. Yeah, so for Emerging Technology Directorate, just looking at our approach to innovation, and I think historically there's been a lot of good intentions in terms of, we want to innovate, we want to get out there and figure out what the best fit from a technology perspective is. But really, we need to introduce some mechanisms that will ultimately deliver a service to the rest of the DISA workforce. So our big push of late has been identifying what are those mechanisms to start, identifying a need and working backwards from our workforce, from our warfighters, figuring out what the challenge they're actually facing is, and then from there, we've defined that problem, we define what we think is a prospective solution, and then we start to prototype and test, and we do that in a very rapid fashion. So we fail fast, we figure out what works and what makes sense. So I think the biggest shift in our innovation approach is getting away from good intentions to delivering through mechanisms, and that's been a really big push for us. And I think the other thing is, we have the tech watch list, we're focusing on, what technologies are out there, which is great. We almost need like a challenge watch list for what's in our workforce and what we're facing today, and we need to really work backwards from the workforce problems, because that'll drive what we see in like startup cultures. They're out there like, hey, we got to figure this out and own it and deliver for our customers. And it's the same thing for us in EM. We need to figure out what the challenge is and then look at what technology is the best fit to solve it.
Thanks, Jared. So the way I see it with AI is we're in the midst of another platform revolution. So we had the computing platform revolution, then we had the internet platform revolution, then we had the social, mobile, and cloud platform revolution. So now it's the AI platform revolution. The challenge is, how do you innovate in a constantly evolving landscape? So one approach, as Jared mentioned, was definitely fail fast. So what we like to do is work with operational stakeholders, find what the problem is. If AI is able to help, and if AI is able to solve it, and we'll see, does it really add operational value? If it doesn't, we pivot, move on to the next one. And the other thing also is that, again, since it's rapidly evolving, we have to learn and be curious. Gen AI is sort of a new way of interacting with computers. Before, you could just give it, discrete tasks and they would do this, whereas now you can interact, you can ask follow-on questions. So it's a different mindset. We also have to upskill the workforce, at the same time, form partnerships, and leverage the investments that are already happening in the department.
So for us, it started with the problem of user experience. And in order to solve the user experience problem, and you will see in a different panel with Herman and other thing about tech debt, we took that problem on a different angle and trying to solve that problem with sensors instead of just investment, and looking at where we need to invest and drive that data-driven decision-making towards the AI ops. That did include like upskilling our skill set also, right? Because it wasn't just looking at the data and making the decision, but driving that user experience investment. We needed to upskill our own game and looking at the data as a problem and using data, machine learning, and AI as a journey. And this is going to be a journey. I won't tell you an operational insight where we are, but we had a successful prototype in looking and deploying AI, whether it's IAP, BCAP, or our endpoint devices, and looking at a real user experience score that we are now publishing to our DAFAs as part of DoDNet. Thanks.
All right. Thanks, guys. So you talked a little bit about it, Jason, on the benefit of generative AI to the analyst. So can you talk about other ways that generative AI or AI in general, right? You own the data platforms within the agency. Can you talk about how you see that happening, and then from the EM guys, what are we doing to work with Jason's team to sort of help move that along?
Sure. I mean the predictive analysis piece is useful, but wouldn't it be cool if we had a future where the analyst is looking at, I know what bad looks like, I'm looking for it, but then I can actually interact with the data and interact with the technology to say, like, now that you've shown me this, what if, and I can just kind of start chatting with the information and present it back. And not only presenting back what I need, but say, hey, I think you're looking for this. Have you thought about this larger data set, right? So I've not seen that technology yet. I ask a lot of vendors about it. I think everybody's got slick sheets to say, hey, we're going to get there. But I want to help you get there. I want to start testing those things because that's the future, right? That's how we're going to be effective. Our adversaries are using AI against us. So how do we tune our tools to see that, catch that, respond to that faster, and be able to protect our environments?
Yeah, I think just to add on there, a couple of critical things we're looking at from the EM perspective is, bringing in that data. What does it look like to pre-process it, get it in the right state, so then it's useful for Gen AI tools. So that's something we're definitely focused on. The other piece I'd say for Gen AI is prompt engineering. So are we asking the right questions and getting good responses? And part of that is developing baseline testing data to make sure, working with the analyst to figure out, hey, if we ask in this way, is this result helpful? Or are we seeing anomalies beyond the tool sets we have today? So those types of things really targets for us that we're looking at.
So, like Jason mentioned, so like Gen AI is a double-edged sword. It can be used by the threat actor, but I think it's also a powerful tool for the cybersecurity professional and also for the analyst. And where we see AI being applied, especially to the data problem, is I think really twofold. First is we want to be able to use AI to get insights faster. And then secondly, we want to be able to provide AI to the end analyst, to the end operator who's not a data scientist, who's not a machine learning engineer, and to be able to interact with the data, be able to get insights, be able to ask in natural language. Has this been seen before? What does this really mean? Has there been any suggestions for any remedial type of actions to take? And then secondly, there's just a vast amounts of data. So how can we use AI to detect anomalies? How can we use AI to detect patterns, and then be able to speed up some of those investigations?
So we have a few prototypes going on within EM right now. Hopefully, at least one of them will make its way out here in the not too distant future. I'm going to go a little off-roading here. I gave these guys the questions ahead of time, but now I'm going to throw them a bit of a curveball. A lot of times, and y'all will hear it walking around the floor today, AI, it's puppy dogs and rainbows, everything's wonderful, it's going to change the world, yada, yada, yada. So let me put you two on the spot. With the work that we've done, we've got one in particular prototype that just didn't pan out well, right? We don't need to name names. We'll protect the guilty. But let's talk for a minute about how, when it didn't go well, or what we ran up against, or even the supply chain issues that we saw as we got into some of these things. So can you guys speak for a minute about that?
Yeah, so I'll start off. So we've been prototyping, generative AI technologies, and one of the things that we see is that these are large language models that have been pre-trained on open source data. And it's good at asking about general knowledge been trained on, but if we ask it enterprise-specific information or knowledge base, it tends to go off track, or it doesn't know, or the term uses, it hallucinates. So the question is, how can we get operational value from these large language models? So we try to build a prototype, taking a large language model, taking our own enterprise data sets to see, can we get authoritative answers from our data as opposed to data that's been publicly trained on. And we've had some interesting experiences. And it's not as easy as it sounds, or it's not as easy as it's been made. Oh yeah, take your knowledge, take all your information, stick it here, and then ask it questions, and you're off to the races. Actually, it's quite a bit far from that. The first challenge is, there are different, there are many different models out there, so you have to be able to pick the right one. Some are in the cloud, some are on-prem. Then the next thing, more importantly, is the data. So we have all this historic data. Now, you have to augment the large language model with that database. That's not trivial. If you take documents, they have to be formatted in a certain way. These documents might have, table of contents. They might have all these other things. And you ask them, it could really take the model off track. And then you run into things where there are conflicts in the data set that you have. So let's say you have thousands and thousands of documents. Some are old, some are new, which is really the correct answer. And then lastly, what we're also seeing is, depending on how you ask the question, you'll get a different answer. So again, if we want to be able to provide operational value, how do you ensure that the answers are accurate every time and all the time?
Yeah, and just to add on there, so in terms of approaching how we would look at technology, I look at three facets. One, is it going to meet the functional requirements of the mission? Two, is it suitable, meaning is it going to work in a DoD environment? And three, performance, like is it going to perform and our end users going to be happy with it? And I think to Deepak's point, you covered a lot of like the functional, foundational. Are we getting good responses that are going to enable the workforce? And at times it's worked, at times it hasn't. I think the other area where we've seen some challenges is suitability, where it may not have from a supply chain perspective, be a tool we want to actually put in our environment. And then other challenges, we've seen some solutions that don't integrate with enterprise identity solutions, which we got to have some sort of RBAC or access control to the Gen AI tooling we're putting out there. So just in terms of suitability for DoD environments, I think there's still a lot of maturing for Gen AI solutions out there. Not that some solutions don't have those capabilities, but some of them we've looked at definitely haven't. And then performance too. I know we've had some that it's kind of like a round robin. One user can go and put a question in, and then the next user just waiting for that to go through. So really, between the functional and suitability, we're taking a deep look at the tooling and figuring out what makes sense.
We've also seen, kind of to pile on to all excellent answers that these guys gave, we've also seen cases, in particular with our first prototype that we did, where things like some of the back-end components are coming from countries that aren't necessarily friendly to us, right? They're open source projects. You go look into the open source project and you realize, oh boy, that's a lot of folks contributing that perhaps we don't necessarily trust. So there's a lot of aspects to it. One other place that we've seen is capabilities that people put into the GovCloud environments. That great, the front end lives in GovCloud, but then the back end turns around and queries a public model. So kind of things to kind of be weary about there. So Raj, let me pivot to you for a minute. Like, from the user experience side, how are you seeing from industry, or what do you have to ask of industry in terms of how do we get after the benefit of the user's experience to remove a lot of that friction, a lot of that, I hate my PC sort of experience, across the whole IT spectrum?
So many of you know, right, DISA's solution to zero trust is Thunderdome. If you look at those data, then we have an endpoint solution, DoD-Net, like endpoint monitoring solution, those data. Then we have a network monitoring solution. So we now have a whole end-to-end kind of, I would say, silos monitoring solution. What we are kind of missing is integrated solution. That's where I really looking at the industry's help to figure it out, that how I can use network telemetry data, endpoint data, application monitoring data, app dynamics or something like that, and then combine together and look at the really user experience. I think AI has a promise to solve this problem really fast and sooner, because AI would be the game changer to really understand all those data points. And then we have a IAP, BCAP, and then Thunderdome solution. Look at what the user experience looks like. With pairing with our tier 1 and tier 0 help desk with large language model that EM is trying to prototype with our J6 organization. I think that's gonna really remove the friction, because user doesn't wanna wait. And second thing is, if you tell user proactively that you are about to have a bad experience, user is fine with waiting. This is what we have seen in industry too. But this is a journey, right? If you look at Google, if you look at Apple, everybody took a time to really get those data and create that journey towards AI. And that's where we are. So I think is an integrated solution would be a great game changer. If somebody has some magic wand or rainbow and unicorn, that would be the one thing that I would look for. How can I take a network data? How can I take application data? How can I take endpoint data and really paint a picture that, okay, this is what it looks like. And that's really gonna change the user experience.
Okay.
But in terms of help desk, I think large language model, I see a friction removing that.
Yeah, we're seeing a lot of movement on that from a lot of the commercial side, moving to more of the large language model backed help desk person, that type of thing. Have seen some really interesting stuff there. Yeah, let's stick with the AI topic just for a little bit longer because you guys aren't going to get enough of that this week. So let me hit one more of this. How are you guys seeing, like, you know, a lot of the stuff that we've talked about thus far has been more our direct interaction with models or standing up infrastructure that interacts with models. What are y'all seeing in terms of the integration from the existing product sets, right? Like, I'm sure you can walk the floor out there and see the term AI in bunches. What are you guys seeing sort of on the back end with some of the existing product suites that we already use?
Yeah, so to your point, there's a lot of programs out there that are integrating AI. We have a few of those inside our portfolio today. You know, I think everybody's going in that direction, but the piece that I see as the biggest challenge is really is not necessarily the model, but getting, you know, shameless plug for our 4 p.m. talk today is getting our hands around the data, and the consolidation is problem one, and then problem two is making sure that we have the right skill set to pair that human analyst with the machine and with the tool, right? Because, you know, to Deepak's point, if we don't know the right question to ask, we're not always going to get the right answer, right? So we might think we know what we're asking, but learning that is really on both sides. You know, we've got to train the model, but we've also got to train our analysts to understand that as well.
Yeah, just to add on to, you know, some of the tools we've seen where AI is built in. You know, I think some things that are very helpful for us is code generation. So a lot of, you know, general LLM capabilities for that. But when they build it into tooling, and we're trying to, you know, build out a flow, build out some workflow, then that's super helpful. So I think that's one area we've seen where they've integrated things, and yeah, that's been good.
Yes, there's definitely the Gen AI aspect, and then if we look at like AI built into products, sometimes I would ask a vendor, hey, why is the AI giving this output? Well, that's why it's giving it. So one thing we sometimes miss is explainability. You know, what was in the data that was found that it made the model give an answer a certain way? Well, the AI said it was 60, so it's got to be right. I said, well, why? You know, can you explain that to us? Because at the end of the day, you know, the person who's going to be using the AI may not necessarily be a machine learning engineer or a data scientist or skilled with it. So if it's built into the products, why is the output a certain way? How can we really explain it?
Yeah, and the data science piece is important there, right? Because, you know, AI is not a magic button. So we need to trust the data, but you know, we also need to verify to make sure that what we're receiving is actually what we need.
And then just to add on to that, just to that point, is that so in the case of generative AI, there are, you know, pre-trained models, and in other cases that we're also seeing, you know, vendors pre-built models, you know, with their own data, and the question is, what data set was it trained on? Can we augment that data with our specific data? Because if we've got certain patterns that we wanted to use, or can the AI system that's in a product, can it learn from our data and then be able to detect patterns and anomalies that's built into our data? So I think it's multifaceted. It's trying to find what's the right you know, fit for a given problem in a given use case.
And that's particular thing, right, where Deepak just mentioned. If I have network telemetry data, and if I ask AI, it's going to give me the shortest path. But for us, the business that we are in, we want to take a particular path sometimes. We don't want to take the path that generally is normal for other people, right? Weight value, we change that to take a particular path. And that's kind of our struggle to route this traffic automatically based on the data that, okay, I don't want to go through this route, right? So those are the kind of the tricks that's where we get skill set issue, and we still need to make sure that person understand port and protocols, that this is the area and the risk model, that this is the reason we are not going to route through this particular area. So we are taking this hybrid cautious model here in order to drive the AI digital transformation journey, because we need to understand that we are following or training the model based on our needs and our risk assessment.
Awesome, thanks guys. So let's shift gears a little bit. Let's move past the AI for a moment. So let's talk about quantum, right? So we've heard the rumor. I have a sign on my refrigerator in my garage at home, right? Free beer tomorrow, right? We've been hearing quantum is coming for some time, but it's always quantum's tomorrow. The reality is it is progressing rapidly. We've met with a number of vendors who are in this space, and the evolution in the number of error-free qubits, which is an operation within a quantum machine, the number of operations error-free are jumping dramatically year over year. So quantum brings a whole different set of threats with it. A lot of times I compare that to Y2K, right? So some of you have haircuts similar to mine. You probably remember Y2K. So like we had a date on a calendar. We had time to prepare. We knew what was coming. The reality is our adversaries are out investing us approximately 10-1 in the quantum space. And they are likely not going to announce when the time has come and when they have a viable machine that will break traditional encryption methodologies. So with that as the primer, Deepak, can you talk a little bit more? Let's talk first about quantum compute in general, right? So like, what does the landscape look like? What do you see as the functionality of a quantum computer? And what are kind of the practical use cases?
Yeah. So, as you all know, a traditional computer or a classical computer represents information as bits. A binary digit could be a 0 or 1. With a quantum computer, it could be 0, 1, both 0 and 1 simultaneously. And then what this does is it basically gives these quantum mechanical properties that allow it to do so, basically allows it to take algorithms and run them exponentially faster. And then, so if it can run it really fast, the question is, what is the right use case for this? Now, just because an algorithm runs on a classical computer does not necessarily mean it's suitable for running on a quantum computer. So I think both of them will coexist for a while. So the question really comes down to is two things. One is feasibility. If you've got a particular problem, can that run on a quantum computer? Are there a sufficient number of qubits to solve the problem? And secondly, is do you really have the right algorithm that can take advantage of the optimizations that are on the quantum computer? With that said, again, not every problem is suitable for a quantum computer. So what we're finding is problem sets that involve optimization, problems that run in exponential time on a classical computer, those are the ones that seem to be good candidates for a quantum computer. We're hearing that currently you can get a quantum computer that's up to several hundred qubits. We're hearing announcements from industry that they are going up to hundreds of thousands of qubits, maybe even 1 million qubits per year. So this space is rapidly evolving. But another common problem with these is that they can do integer factorization. If it's integer factorization, it really, it could break the RSA encryption and really undermine our PKI infrastructure that we have in place. And we're hearing about these store now and decrypt later attacks. So even though our comms is encrypted, well, let's harvest it. So whenever a fully functional quantum computer is available, the adversary is able to decrypt what information we have. So we're closely monitoring, what these are able to do.
Anybody else any thoughts?
Yeah, so as you know, we are in a business, right, where failure is not an option. And we have to live by the rules. Our adversaries doesn't. So that makes our life a little more complicated than our adversaries. And we have to be right all the time, while they can be right only once. Right? So keep that in mind when you're proposing solution, that it should be able to scale. Because another issue we always see is the scaling.
Yeah, so sort of along those lines, and one thing I do want to kind of put out there to our industry partners is we're starting to try to look at how we would leverage quantum, right? So one of our engineers came recently to a few of us and said, hey, we should get into quantum as a service. And the initial reaction was, I don't know about that. Like, it's still evolving quite rapidly. We're not really sure. We haven't seen the demand signal. I don't know that we will see the appropriate demand signal to be able to pay for a single quantum computer dedicated just to us. Even, I mean, there are parts of the department if the department banded together appropriately. But we're facing a similar challenge to what we did early on with cloud, where we want dedicated compute because we want separation, and quantum's not going to come along that quickly or quickly enough that the price will get sufficiently low that we can sort of do that. So we need to start to think through how we operate to make those queries on those specific algorithms in a shared compute environment, but to do it securely and do it with enough separation that we can demonstrate, comfortably that the data is not being mixed or that sort of thing. So, I'd really be interested from industry to hear more about what industry's thinking in that space. I know this is kind of niche, but I'd rather start to look at it while it's still niche before it becomes mainstream and we're late to the game. So let's talk a little bit. You mentioned a bit about the quantum. You mentioned a little bit about the threat that quantum poses to cryptography, traditional cryptography. There's a lot of debate if you ask different engineers exactly how many qubits it'll take to crack specific algorithms. It's generally thought that AES 256 and above is safe for now, but that below, you mentioned RSA, are potentially in trouble when quantum hits its stride. So can you talk a little bit about what's going on in NIST, what we are doing, how we are prepping to be ready to jump in once the particular algorithms are approved?
Yeah. So we're tracking the NIST standardization process. So NIST has been at this for a couple of years right now, and the idea is to have a next generation of algorithms that can run both on classical computers as well as quantum computers and be able to withstand these types of attacks. Very recently also, NSA has put out guidance in the form of CNSA 2.0. That's the Commercial National Security Algorithm Suite. And it mentions crystals Kyber for key management and dilithium for digital signatures. And so the idea is that at some point we will transition from these RSA-based elliptical curve Diffie-Hellman and elliptical curve digital signal algorithms over to these post-quantum algorithms. What we also see is that I don't think that these two algorithms that they put out are by any means finalized. I think there'll be new variants coming out, as newer attacks get developed, we'll be seeing either variants or new version of these algorithms come out. So the question then becomes is what does a transition to a post-quantum world look like? There's also been some guidance putting out from NSA that's saying starting 25 all the way up to 2035, pretty much all the IT systems that we use will have to be upgraded. So just imagine all the functions that we do. We authenticate to a website. We send an encrypted email. We digitally sign a document. All that will now have to use these newer post-quantum algorithms. So some of the steps that we're taking to prepare for this migration is, first of all, we're trying to experiment and prototype with these algorithms. We're trying to really understand the interoperability, the computational overhead, and the performance impacts of these algorithms. What would it be to run like in a disconnected environment? How would they run in a bandwidth-constrained environment? What's sort of the computational overhead? So we're better prepared. How would it run on mobile devices? So we're just trying to right now experiment with some of these prototype algorithms. The other thing that we're also trying to prepare for is that to get an asset inventory. When we migrate, we want to be able to know what versions of cryptography do we have on any of our devices, on our networks, which ones we're using. And then more importantly, when we do migrate, if there is a vulnerability, if there's a vulnerability in these algorithms, how do we know which ones we need to migrate and what does that landscape look like? And then lastly, but more importantly, one of the things that DISA does is it also runs issue certificate and runs these issue certificate authorities for the department. So all those would have to get upgraded to newer algorithms. So I think there's a lot happening in that space, but I think as soon as we get go ahead that these are fit for use on national security systems, essentially we're taking right now a risk reduction activity. So we want to be prepared for when that day comes.
So the one thing to sort of add on to that, right? Deepak talked about a number of the things that have to be done, why we're testing these sorts of things. To give you an example, when we rolled off of SHA-1 and we moved to Job 256. It took us approximately 7 years to roll the department, right? So it's not as quick as snapping your fingers. We will try to attack from the transport layer upward, thinking that you'll get the most impact at the transport layer, and then work your way up through the stack. But crypto roll is not a trivial or a fast process. Now, in a time of emergency, sure, we could probably go faster, but you're not going to cut it down to 1 year or anything like that. We are every bit right now of traditionally 7 years. So something just to keep in mind if there's also ideas around how it can be done more quickly. So let's see. We're going to roll back briefly for the topic of AI. We'll do another 5 minutes or so, and then we'll open it up to questions. So let me go back and hit on. Let's talk about the on-prem versus hosted challenges. One of you mentioned that, maybe it was you, Jared, that mentioned it earlier, about sort of that on-prem, even from the hardware layer all the way up through the software side. But open it up to any of you guys. Jared, if you want to fire off first. But
So I think there's two areas, which you look at on-prem versus cloud-hosted, and GPUs and LLMs. So GPUs, can we get them on-prem to start, in our case, doing test and evaluation, and then build from there, and like we've been prototyping different platforms to figure out what makes sense. So GPU availability is a big challenge, I would say, and I think the other challenge, not just on-prem, but dedicated cloud regions. So talked to a lot of the cloud providers, and if it's commercial, we likely can get it. And if you think about cloud, it's on-demand IT delivery. I'm not sure we're going to be so on-demand with GPUs in the dedicated cloud region. So we got to figure out from a DISA and DoD perspective what the demand signal looks like to help, get that GPU push for cloud and dedicated regions, because that's, you look at where the data is, it's Gov, IL4, 5, 6, beyond. So getting GPUs is a huge step one and a big challenge for just test and evaluation, both on-prem and cloud. The other piece I'll say for the software piece and really the other big areas, LLMs. So we can get all the open source LLMs on-prem. We can test. We've been doing that and experimenting, figure out what models we like and those types of things. But when we're looking at the closed source models, often we can't get them on-prem, and we do need to use them via some cloud environment. And then the challenge becomes we want to use it with data that, like I said, is IL4, IL5, IL6, and then we go to look at what's in region for cloud service providers in terms of their AI capabilities, and it's still in the process of getting deployed into the dedicated cloud region. So I think that's the other challenge for us, getting access to those closed source, highly performant LLMs within the dedicated cloud regions is something we'd really like to test and experiment with. That's where our data's at, so we need to use those technologies. So just to kind of circle back around, the two big challenges I see, both on-prem and cloud, are GPU availability and then getting the right LLMs, getting access to them for us to work towards different use cases.
And I think, and just to kind of add on to what Jason said, so it's definitely what the GPU availability and the LLM, but I think in addition to that, as we're trying to build Gen AI-based application or use Gen AI for enterprise use cases, there are a lot of other components as well, such as, for example, databases, there are orchestrators, there's the authentication system. So the question is, we want to be able to offer, let's say, an integrated solution. So now the other piece is what's the availability, whether it's on-prem in terms of an application, or if it's coupled together with clouds, with cloud native services. But are those services in regions? So as we're trying to plan out, what do we do? That's also another consideration we have to think of: what's available on-prem, what's available in a certain region, and then that way we're just able to, offer an integrated, capability to the end user.
All right. Any other thoughts, guys? All right. So with that, we're going to open it up to questions. So don't make us stand up here and look foolish. Please approach the microphone. Come on, Johnson. You got one, I'm sure. Break the ice for me, buddy.
So this might be outside of the topics discussed. We hear about quantum. There's quantum computing. There's PQC, and there's QKD, and then there's quantum sensing. Are you guys doing anything with quantum networking and quantum sensing at all?
So I think we've looked at those technologies. Again, we're trying to find where the demand signal is, where the exact use case is. And one thing I can say about QKD, that is something we are definitely not looking at. I mean, there's an opinion out there. Again, for those who don't know, QKD is essentially using quantum computers to be able to share encryption keys between different devices as a way to secure encryption. That is something that we're definitely not looking at. There's an opinion out there that it's not as safe or not as mature yet, and it still has some others. But we're trying to see, with quantum sensing and quantum networking, where exactly that would fit.
And John, you also need to understand we have millions of devices. We have a third largest network in the world. So deploying something that is not yet ready could really backfire on us big time and for our warfighters' readiness. So last thing I want to do is solve a crypto problem. I call it shooting ourselves in the leg.
But I will say, Johnson, if that's something that DIU would like to work with us on, we would gladly.
Absolutely. So we have a new emerging technologies portfolio. We'll talk more.
Okay. This is Johnson Wu, by the way, from DIU. I picked on him. We've worked together quite a number of times over the years. So thanks for breaking the ice. All right. Yes, sir.
Steve Goldsby, I'm with ICS. So I hear the term demand signal a lot.
Yep.
And so in the frame of large language models, how do you, this will be a multi-part question, so prepare yourself. How do you define demand signal? And then I would argue that, as we saw with these open models, making the capability available creates this hyperbolic demand signal. So
Yep.
It sounds like there may be a chicken and the egg. So if you would just kind of address that.
Sure.
Oh, and DISA has a limited budget as well. I know.
This has a what? I'm sorry.
A limited budget. I'm painfully aware of
Oh, I'm glad you said. He said limited, folks. Limited. He didn't put an "on" in front of that. Limited. I can hit it, but
Yeah, I'm just thinking back to the question here. So yeah, in terms of evaluating LLMs, part of it is baselining and figuring out what, just take a Q&A bot as an example. What kind of questions would the workforce ask, and are we getting the right answers? And then for us, doing testing against a variety of LLMs to see, what size LLM is sufficient, and, how can we do that price to, performance ratio properly. So I think for us, where we're at currently is testing different LLMs to figure out, how much of an LLM do we need and what kind of performance. And part of that is just developing the baseline data to go out and do that.
And in terms of demand signal, there is already internal customer, right, DoDNet. So we already have a demand signal. It's just making sure that that LLM is ready for production. Back to John's comment to me, right, on that is we don't want to put something out where users get more frustrated than what they are already.
Yeah, and just to add on there, our focus is prototyping with, very controlled scope use cases to get it in front of the workforce, gather data on what that demand signal looks like, and then we'll be better able to articulate, hey, this is our GPU demand, this is our LLM demand, and go from there. So small prototyping to gather that data to better refine the demand signal.
And then, so the other aspect that we're also looking at is, so we have these large language models. Some of the use cases that we're seeing emerging, and we still have to prove them out. Of course, is this Q&A bot. You can ask it questions, get answers. We've also been hearing things about people want to summarize documents. Hey, there are these really large, hundreds of pages of documents. Can you summarize one? Then the next question is, hey, can you write me a report? Can you take all these 10 documents that I have, understand them, and write me a report in a particular format? So some of these we want to be able to see what the limits of the tech are, what the limits of the large language model are, but again, test them in that right context, and then find that operational user that says, yes, these really benefited us. We're able to achieve the ROI, and that's kind of what we're also focused on at the same time.
So let me take a slightly different tweak on that too. When we talk about demand signal, the demand signal is certainly there, right? I was having a discussion with Lieutenant General Skinner yesterday, as a matter of fact, and I use the term measured, right? So you can even look out there across industry right now for AI. There have already been a number of, if anybody saw the pin or the rabbit, or these AI-enabled devices that you look at and go, what in the world? Great, we delivered an AI product. I use the term measured because I don't want to deliver an AI product. I want to deliver a product that is useful for the department and that has capabilities that are ultimately beneficial for the department. I don't want to do it as a science experiment. We will do science experiments like the one I mentioned that just frankly didn't pan out, so we're going in a different direction. So the demand signal is certainly there. I think we also need to figure out where we assign the assets. My perspective is I think Jason's area is the most ripe for a lot of these features. How can we better augment our analysts to get the bang for the buck and help the analyst from moment of an incident to resolution. Summarizing a document, definitely useful. I saw Doug Packard back there somewhere. From their side, from the from the procurement side and writing contracts and that sort of thing, definitely useful there. But I would definitely my first stop, in my opinion, is folks like our the ID6 team, our folks at DISA Global, across the board, those people that have to actually defend the network on a day in, day out basis. Anyway, I've rambled long enough. Yes, sir.
Fine, thank you. Hi, I'm Tim Greer from the DISA CSSP transformation team. And I heard Mr. Abernathy mention that there's several tools are being evaluated right now in the AI arena. I wonder is it okay to mention what those tools are that we're looking at?
So we have several valued mission partners that we're evaluating products with. We do have tools like Splunk in our portfolio today. We also have Elastic in our portfolio, and multiple other tools we're looking at. How do we integrate? How are we going to integrate those? For lack of better words, a chatbot or somewhere where I can actually interact with the existing programs. That's really up.
So that was kind of the segue into my other question, which is what evaluation criteria are being used to evaluate these. So do you have just a brief summary? Yeah.
So I sit down with mostly the DISA Global team, but also the 357, the CSSP team, to develop vignettes so we actually know how to measure. Back to Steve's point, measure what success looks like, right? Because as we walk the floor, everybody's got AI, but is it actually useful to me? And is it operationally useful to me? And can I actually get an operational benefit? Is really what's important to me. So the analyst will define that vignette. As the portfolio manager, I can dream up crazy ideas, but if it doesn't provide operational impact, I'm just delivering something that's not useful.
Okay, cool. Last one was more along the area of quantum. Actually, I was hearing a lot about large language models and how we can extend those. And my question is there a move, and I guess this is more for perhaps Deepak, a move towards developing a standard, maybe, I haven't heard the word ontology yet, ontology for the extending the large language models in the domain of cybersecurity?
Yeah, so that's a good question. So I think we're looking at different approaches. So, one is let's take a pre-trained large language model that's out there. So there are language models, there are cyber models, there are, again, domain-specific models, not relevant to us, but models for medicine and so on and so forth. So we're also trying to see, are there models specifically trained on cyber as they are trained on language? That's one area. The other aspect also is that how do you, again, these models are pre-trained up to a certain date. How do you extend their knowledge with enterprise data? That's a technique that we're looking at called RAG, Retrieval Augmented Generation. Another area that, again, these are all we have to explore depending upon where the right problem is potentially fine-tuning. That is, very resource intensive, also time consuming. Do we really want to go there? So we're just seeing how our industry partners evolve. Again, it's a fast growing landscape. I think every month there's a new announcement, and people mentioned you would need to fine tune, but now with a lot of the other improvements, there's less of a need to fine tune. You can do a lot with prompt engineering. So I think we're following the space, and we'll be able to use the right approach when needed.
Thank you, gentlemen.
So one, I wanted to hit on it real quick while you were up here as well. One of the spaces that we see sort of growing that's of interest, and last week I was out at a conference with a number of folks from our J9, and we saw some things there with respect to, well, Jeff dubbed it AI as a service, right, Jeff? But we're starting to see industry move in this pathway of API gateways that sort of allow for broad query and then go through some level of gateway where you can apply rule sets, apply guardrails, that sort of thing, and then allow the query of a large number of LLMs behind the scenes, right? LLMs that are tuned for specific purposes, whether it's on security-related data or whether it's on contract-related data or what have you. I think that's the direction that things are going to move in generally rapidly, because right now it's a bit wild, wild west, and you have to apply those guardrails and that governance across each one of them. Starting to see that emergence of sort of a central API sort of gateway governance approach. So we're over the next year, over the next several months, I'd like to see us explore that. All right, yes, sir.
Good morning. I was just wondering about the scope of the research and emerging technology that you're talking about. Are you staying too limited to the strategic side, or are you also looking into the tactical network side, possible vulnerabilities and AI being implemented in that realm?
So,
yep.
Actually, I'll start there and then let you guys think about your answers. So one of the things that we're looking at inside of PEO Cyber is how do we do automated vulnerability detection, right? And how do we push that down to not necessarily to a tactical edge, because I really think what you're asking, but could we do a flyaway kit that does an automated validation? Think about going on board a ship or going to a base post camp station in a remote location, and doing a security assessment of that environment, leveraging AI to go out and find things that a traditional host-based scanning wouldn't find, right? So we're evaluating those products. I think there's even some things inside EM that you've looked at.
Yes.
And we've actually deployed some capability at our IAPs that's starting to look at that capability as well. So my vision is we take that off the IAP, we push that down as low as we can. I think timeline we're probably in the 12 to 18 months before we really visualize those, that reality. But it's definitely on the roadmap. Yeah, we can talk more about it. Yeah.
So in terms of us, I would tell you that partnering in, I think Jason and I were just talking about a few minutes back, looking at a single sensing, that's where the DISA is probably going to move. We are converging and merging together as a single sensing, because sense once, use many. And that sensors are giving us the data to be, regardless of whether it's a cyber or user experience or network issue. Basic idea is here is that using the sensors for such a large network to really reduce the time to restore service, as well as understand the cyber anomalies. Like host 1 is talking to host 2 all the time, and we are aware of that in data bytes. But if that host is suddenly going with a large data going out, we get automatic sensing and alert. And there is no humane possible way for such a large network that we can do it alone, right, with the human way. So that's where we are really moving forward. And I think ID is PEO Cyber, sorry, I still get the old name in my mind. And emerging technology is a big part of it. And then taking it down, using the edge compute provided by our J9 people, helping those data for J6, which is the endpoint provider, as well as J357 to drive towards AI ops, so we can solve problem immediately. Over.
All right, time for one last question. Yes, sir.
With regard to your comments in comparing PQC with QKD, I respectfully disagree. Indeed, to be scientifically correct, QKD is the only key distribution mechanism for which the mathematical proof of unconditional security exists. And I can refer you to several papers by scientists such as Peter Shor of MIT, John Preskill of Caltech. So just rejecting QKD and stating that, hey, it's not safe, it's not scientifically correct. Indeed, there is no mathematical proof of unconditional security for PQC approaches at all. PQC is just a conjecture. So with all due respect, I disagree. So that's why we are pursuing both methodologies, both PQC and QKD. In fact, we are going even beyond point-to-point QKD. We are looking into satellite quantum communication. We are looking into entanglement-based long-distance communication for QKD because of the importance of this technology. Just to make sure that you can also hear different perspectives here.
So that probably warrants a far deeper conversation than what we're going to get into here. You went full mathematician on us at 0900.
That's who I am. I'm a scientist.
And I appreciate that, right? Like we should have those healthy, open debates of, hey, let's have it out. It's one of the favorite parts of my job when I get to lock a bunch of engineers in a room and we get in front of a whiteboard and we call them throwdowns and we get in the room and we have it out and we make a decision and we either walk out or we don't. But we will have a decision when we walk out. So I'd encourage you guys to have a conversation as soon as we're done. So,
by all means.
All right.
Thank you so much.
All right. With that, I thank you guys. I appreciate your time up here. Thank you all for showing up at 0815. So enjoy the rest of the conference. Thanks, everybody.